You're good.
Welcome to our Intro to Tech workshop. Today we will be discussing GitHub. We will discuss some of its tools, some of its features, and why it's so important to use it for projects and for collaborations. I will begin with some general ACM announcements, and then we will get to GitHub. If you have any questions, you can put them in the Slido or in the YouTube chat, and we will get to them when we get a chance. I'd wanted to remind y'all to sign into today's meeting and for any ACM meetings that you watch, because for every time you sign in, that is one more entry towards winning that prize in the drawing that we have towards the end of the semester. Some of the prizes include a 3D printer. We will have some ACM swag and stickers that you will have the chance to win. So please make sure to sign in. Also, please forward your registration if you signed up to volunteer for the San Antonio Youth Code Jam to council@acmutsa.org. Please pay your dues. You can pay these by going online to acmutsa.org under the tab Join, or you can also scan this QR code that we have provided for you. This will direct you to the link. Please join our Slack. This is our central communication platforms where we post all the announcements, the events, and the opportunities. Through Slack, you also have the opportunity to chat to any of the officers if you have any questions. You can contact them through here. This is our main platform that we use for communications. We do have other platforms such as Discord, ACM, YouTube, Instagram, Twitter, Facebook, and LinkedIn. We recently made our Discord channel. Our technical officer recently made it. He did a really nice job, so please check it out. And we do have some events going out throughout the week. We have ICPC on Saturdays from 10 to 1 p.m. If you want to get that technical interview practice, please attend their Saturday meetings. If you have a project idea that you don't know how to go about, you need help, attend the Rowdy Creators meeting on Sundays from 3 to 5. ACM-W, the women's chapter, will also have a meeting on October 6th at 5:15 p.m. They will be featuring JP Morgan Chase, and the meeting will be Day in the Life of a Software Engineer. So this meeting will not be this week, but it will be next week, October 6th. Our general ACM meeting will be again Wednesday at 5:15. We will be featuring a UTSA professor, Dr. Max Cougar. He will be talking about research on the motivations of computer hackers. It's a very interesting topic, so please attend this meeting if you can. Okay, now we will get into the discussion on GitHub and the features and tools. So it's important to understand that Git and GitHub is a little bit different. Git is a version control system, which means that the system records all the changes made to a file or a set of files. This is very useful when you're collaborating with other team members. It tracks changes made to the computer files. Git is for the local repository, so in your computer. So it's a little bit different than GitHub. GitHub is a cloud-based hosting for Git repositories. GitHub provides a graphical user interface for some aspects of Git. So it is important to understand how to use Git and GitHub because it's very useful for collaborative projects. with Git and GitHub, you have a local repository and remote repository, where I will discuss further of what local repository and remote repository mean in the next slides. But it's important you understand that you can approve changes as team members of a project through this. You can see the different versions of the program. You can revert to past versions without having to duplicate multiple copies of code. It is a place where you can display your code and edit your code. GitHub is also very useful because a lot of students can put it in their resumes for companies to look at the programs they have done on their own or on a team, and companies can go to their GitHub and see what they have been working on. Of course, it's up to you whether you want certain projects private or some programs accessible by anyone. So setting it up is not very complicated. Installing Git, it's already installed in Linux and Mac operating systems, or you can download it, Git scm.com downloads, or if you have Windows, installing Git Bash. You can make sure that the Git version is installed by using the command git -- version. For GitHub, you would need to create an account in github.com. You can use your UTSA email, and to get the GitHub Student Developer Pack, which is a bonus if you use your UTSA student account. So I have been using the word repository a lot, also known as repo. What this is the code base as a whole that can be stored either locally or globally, also known as remotely. What global repository is, it is the base code, the code base that is stored on an online platform like GitHub. You would need to create a GitHub account, like I mentioned previously. You could click new, and that would open a new repository. For the local repository, that is a code base stored on your computer, locally on your computer. This can be initiated by the command git init. What that does is it creates a folder called .git, and it makes a repo, and it will track any changes, and by default it creates a master branch. We will further explain this in the demo. I think it'll make a little bit more sense in the demo when we go through it. Okay, so for the username and email for the local repo, you can do this by using the command git configure username and git configure user email. You would have to do this the first time to make sure that you have a username and email associated with your repo in order to have that connection. This helps configure values, and in this case, the name and the email, to local and a global value. So in order to connect your local repo to the global repo, it's important to understand the command called git add. What git add is that it adds files to the Git repository. You need this before you can push and pull. I will further explain in the next slide what push and pull mean, but it's important that you have git add so that you have that connection with the local and global repository. And this link right here that you see, HTTPS, that link is directly from the global repo. Each repository that you make has its unique link that is used for linking on your local repo. And we will show that in more detail in the demo that we have after this presentation. So a push is when you're ready to update the global repository with your local committed changes. So what that means is that from your local repository to the global repository, those changes get pushed. You can do this by using the command git push uorigin master. After you have specified your upstream using the U flag, you can just use git push command. So what this does is from the local repository, it updates all the changes to the remote repository. Now, pull is kind of the opposite of push. Pull immediately downloads and gets all the code from the global repository to the local repository to ensure that there is a shared history and that both the repositories match. When you need to pull when you want to start changing code from the local repository. Before you push, pull from the global repository to make sure that you have the latest version of the code. In the local directory, as you can see in the example here, git initialize and then git remote at origin, and then you would put your repo URL that I mentioned, and then that's when you could pull by using git pull origin master. So pull, it's the opposite of push because it fetches and downloads from the global repo and updates it to the local repo. So commit is another vocabulary term to get familiar with. Commit tracks all the changes in a file and keeps track of all the changes. Each commit has a unique ID with the time that it changed, when it was changed, and which files were changed. Each commit has a message from the commit author that describes which files have been changed and what the change is. This is an important feature because you don't have to keep duplicating copies of your code. Instead, you can keep it all in one place and you can revert to see older versions of the code. You commit from the staging area. We have an example right here. The git commit -m is where you could put the message detailing what the change is, and then this is an overview of the git commands, and some of the vocabulary that I talked about. So working directory is where you work on to get your code locally until you are ready to start submitting the changes to the repo. The staging area is your local code that is ready to go to the repositories held. And then you can check the changes by using git status. Git status will let you know which files have been changed, and it will let you know which have not been committed yet. The local repository, where your change code is held on your local device. The global repository is where your changed code is held for you and where your team can have access to it. Like I said, git commit is very helpful because you don't have to keep making copies of your code with changes. You can all keep it in one place and you can see all the versions of your code and you can revert back to any version that that you want or keep the original program. Okay, next I will pass it on to Janelle. She's going to explain some other features and tools within GitHub.
Yes, thank you, Vanessa. So I'll wrap up with the last couple features that we have here, and then our vocabulary terms, and then we'll do a demo where we kind of walk through everything in this whole process together, so that hopefully it makes a little bit more sense. But thanks, Vanessa, for all that vocabulary. So the next piece of vocabulary that we'll look at is master versus a branch. So you might have noticed on these little like code snippets, it says master right here. And that is the name of a branch. And so master default gets created whenever you have a local or a global repository. And master is the branch where all of your code will eventually get merged back to. So master is the branch, you can think of it as the one where that's what you're turning in, like when you have your project done. So you want to keep master your most updated code, the code that you test in other branches, and then merge it back to master. So master will be that final branch that you want to keep really clean and make sure nothing happens to it. And so when we want to test code or when we want to add something, we can do it on a different branch. And so a branch, it's a unique set of code changes. So when you're naming your branches, which we'll go over kind of how to do that next, when you're naming your branches, it's a good idea to name them after what change you're trying to make. So this necessarily isn't like the best example, because here we just named the branch 1. We have master and branch 1, but that doesn't really tell us any information. So when you're doing this for your projects, it would be a great idea to name the branch after the code changes that you want to get accomplished in that branch. For example, if you want to add a certain function, title it something like that. And so branches are great for the team aspect of GitHub, because you all have this master global repository. But if you want to make different changes in your local repo, you can pull master, and then in your local repo, you can create a new branch to say, okay, I want to work on this change. And somebody else can create another branch to say, I want to work on this change. And that way, when you push all of these branches to get merged back with master, you can see the names of the different categories of code changes. And again, this is like really conceptual right now, but hopefully it'll make more sense in the demo. So like I said, the idea of branches is you make the code changes in that branch, and then you merge it back to master, and master will be your finished project. And so how you create a branch is with this command right here. And we also have an example. This is in Git Bash. This command is git checkout and then the B flag, and then you name your branch. So we named our branch 1 here. And once you hit enter, it'll immediately create this new branch, and it'll put you into that branch. So we're no longer in master, we're in branch 1. And so if we wanted to go back to master, it's a very similar command, but we don't need to create a branch because we already have master. So it would be git checkout and then the branch name. So in this case, we would say git checkout master, and then we would have this new line where it shows we are in master again. But be careful, because for branches, if you create a branch through the GitHub page online, if you go to this like master button and you create a new branch, that's on your remote repository. And so your branch won't be created on your local repository as well. So just make sure that you know which branches are in your local repository versus your remote repository. And personally, I like to kind of keep them the same name. So since I have branch 1 here, I'll push to branch 1 up here, just to avoid any confusion for myself. So that brings up our next topic, which is a pull request. I mentioned pushing branches to merge back to master. And so when we want to change master on our remote repository on GitHub, we need a pull request. And so GitHub is really nice, because anytime you use the push command in Git Bash from your terminal, anytime you push to your remote repository, anytime you push a new branch to your remote repository, it will pop up in GitHub with an option to add a pull request. And so what a pull request is it lets you and all of your collaborators know that, hey, I have a new feature that I want to add to master. Everybody come look at it, or this is where it's being added. These are the changes. And so when you're creating a pull request, something really nice about GitHub is you can request for your collaborators or your teammates on GitHub to go and review it. And then once everybody reviews it, you can click merge and it'll be merged back to master. Another great feature of GitHub is it provides visualizations for the changes that are happening. So if we pushed our branch 1 to the origin, to our remote repository, and we wanted it to make changes to master, this pull request would show us a visualization. It would highlight everything in red that's now gone, and it will highlight everything in green that's just added. So you can see what's been added, what's gone, and also if there are any conflicts, which we'll talk about in a minute, you can resolve those there. So the pull request is how you can merge branches on GitHub. Now, what if you want to merge a branch on your local repository? Well, that is accomplished through the merge command. And so the code for it is here. We changed branch 1, we made a commit, we changed it. But then let's say that we want those changes in branch 1 to be reflected in master. And so what we would do is a merge. And so this is a way to keep master the same. We keep master the same, and then we take our branch and we make changes to it. And when we're ready to merge back, we use this git merge, and then the name of the branch we changed. But when you're doing this command, make sure you're in the branch that you want to change. So we want to change master, so we go to master, and then we type the command git merge branch 1, because we want branch 1 to add its changes to master. And so this is how you would merge branches on a local level, whereas the GitHub, it takes care of merging with pull requests on the remote repository level. And so you can run into some problems here. As I mentioned, GitHub shows you a visualization of the different changes you've made. And so what happens if when you're trying to merge, you have a change somewhere in master, and you also have changes in your branch. And these changes could be happening on the same line. So let's say in our file, we had a print statement. And here we took out this branch because we wanted to make that print statement say hello world. But then we go out of this branch and we change master, and we want that print statement to say hi. When we go to merge the branch back to master, there will be a merge conflict because we tried to change the same line of code in both branches, and Git doesn't know which one that we want to accept. And so this is what I was talking about with the visualization in GitHub. It'll show us that we're trying to change the same line, and it'll let you know on GitHub which one that you want to which one that you actually want to change. So we can say, oh, my bad, like I really wanted it to say hello world, and we can change it right before we make that pull request. But in general, it's a good rule of thumb to make sure you're constantly pulling from master and you keep the same version of master. So we don't want this red dot here, which is that change. So as long as you make sure that your master is the most updated and you're pulling that master to whatever branch, then you should be able to avoid merge conflicts. And there are also some more advanced GitHub and Git commands to where you can go back and revert to other versions, but this is kind of as far as we'll go for this presentation. So the last thing we'll talk about is cloning. So cloning is getting the code from the global repository or the remote repository to your local repository. And you might say, oh, this sounds really similar to what Vanessa was talking about with polling. And that's because it is. But when do we want to use poll versus clone? So when we poll, we're typically wanting to update our code to get whatever our teammate just did a poll request and changed master for. But when we're cloning is when you just want to get a clean copy of the entire code. And so cloning is for getting the entire code, but polling is just for getting those like intermittent updates. But we do it in a similar way. So Vanessa said that the command was get poll origin master or get poll origin branch. And so what we need here is we'll do get clone, but we need the address that we can get from GitHub. So if you click on this code button, then it'll show up with an HTTPS address, and that's how you can clone the entire repository to be on your local repository, is if you type in this command. So that's it for the presentation. So now we will get into a demo of some GitHub and Git commands through a simple like calculator program. And we wrote this in C. So give me 1 minute to adjust screen sharing. And then we will get into the demo. All right. So I'm sharing my screen again. This is what GitHub looks like. So this is my account. I'm logged in. On the left, I see all of my repositories, and so that's great. So this is our global repo, and I have one here from Vanessa that is calculator code, and it says that it has code for a simple calculator, and we'll use it for this demo. So that's perfect. So we can go in on GitHub and we can kind of mess around. We see this is the code. It has some files here. It has a README file, which is what we're seeing right here. A README file just contains descriptions, and GitHub can create one for you automatically when you start a new repo. And so let's kind of poke around here. I see there's this demo.c file. And so this is some C code. I can see that we have a main function, and it looks like it's for a simple like calculator program. So let's get this code onto our local repo. So I'll show you how to do that. So since I'm on Windows, I have git bash. So I'll go to my bash terminal, and it looks like this. Make it a bit bigger so hopefully you can see. All right. And so we are currently in our bash terminal. And so I'm going to use some Linux commands in here. If you haven't seen them before, you can look at a Linux like cheat sheet, but I'll try to explain some of the commands I'm going through. And so right now my goal is to get this code from this global or this remote repository into my files on my computer. So I want to go to the place where I want these GitHub files to be. So I personally, let's say I want them in documents. So I go CD, which stands for change directory, and then we'll go documents. So now I'm in my documents folder. Let's make a new folder for this code that I want to change. So we'll go make directory, and we'll say it's going to be a calc program. And then we'll go into that new directory that we created. All right, so we're in this calculator program directory. It's the same thing. You'll see that if I bring up my file system and I refresh it, here's calc program. I can go in there and I can see that it's empty. So we've created that new file, so that's all good. You can also check if it's empty by saying ls, and I'll list the contents of the directory you're currently in. All right, so to get the code here, what we want to do is we want to initialize a local repository because we need that connection between our local and global Git repositories. So I'll do the command that Vanessa went over, git init, and that initialized an empty Git repository. So like Vanessa said, when we do this, it creates a .git file. And so that's how we know that, okay, we have Git and we have a local repo. So the next thing is we want to make the connection between our local repository and this remote repository. And so we do that with the command git remote add origin. And then we take the URL from this GitHub. So I'm going to go ahead and copy the URL, which can be found if you hit this code button. And in the clipboard, that'll copy the URL for you. And then I'll go back into Bash and I'll say, all right, git remote add origin. So this is creating a connection to a remote repository and we're calling it origin. And so I'll paste the link here. And so perfect, we have this connection. Just to make sure we have this connection, let's go ahead and we'll do what we set out to do. We'll pull the code from this GitHub repo onto our local repository. So the command for pulling code is git pull, and where we want to pull from is the origin connection, and we want to pull from the branch master because I'm in master over here on GitHub and I can see this is where the code is that I want. So we'll say git pull origin master. And so now we see that it took this a couple branches. So we see that it kind of did something, it added something. So let's go ahead and see what's in our directory now. And there it is. There's the demo file and the README file right from GitHub. It's the same ones. So now it's in our local files on our computer. And this is like the file system GUI that we can kind of look to make sure they're there. So that's perfect. So now let's see if we can run this code. So I'm going to go into an IDE. This is just a random IDE for C that was just really easy. So I downloaded it. So let's go to calculator program in documents because that's where we saved it. So here's calc program. All right, and let's open this demo C file. So when we open it, we can see the code, and it's the same code that was on GitHub. So let's run it and let's see what it does. Let's see what code was on that GitHub repo. So it pops up with this terminal, and I see it says enter an operator, plus, minus, times, and that has a to do and division. So let's enter a plus. Enter two operands. So we'll do 3 and 4. And what this program output was 7. So it just output the result of that operator with those two operands. So let's see what happens when we hit division, because that one was a little weird. It said to do. So let's see what happens here. So if we do division, and we'll do 6 divided by 3. All right, so it says to do, like we need to make the division case. Okay, so I guess that's what we'll do, and then we will upload it to the GitHub repository, the remote repository, and that will be an update to this code. So if you're not familiar with some of this code, it's basic like C code. And so you can look up some of the functions. We're printing something, we're scanning for input. And then we have this switch case. So depending on the operator, we'll print different things. So I see for printing the plus, we do 2.1 a float. That is the first operator we get, or first operands we get, plus the second operand we get. So let's try to recreate that for division. So we have this print statement down here. And we'll do the same thing that we did before, the same format. So we'll say to 1 decimal place, a float, times to another 1 decimal place, a float, equals to another 1 decimal place and a float. And then we'll do new line. And so this I copied from this, but we're doing times here. And so we want this case to be division. So I'm going to replace this with divides, and that's what it'll print out. And so we'll do the first operand the program gets divided by the second. And that operation will be first divided by second. All right. So let's see if we messed up at all or if we did this right. So we'll do division, 6 divided by 3. All right, so we have 6 divided by 3 equals 2. So that looks good. I just need to change this to do to just the division, but then it looks like we'll be ready to upload this change code to GitHub. We'll test it just one more time. Got rid of the to do. And then 6 and 3. Perfect, so it looks like it's working good. So now how do we get this code to GitHub again? Because you'll notice if we go, we're in our local repository, right? So let's see what's in the demo.c in our local repository. So if we do vim demo.c, it'll let us look at the code. And I can see that we have the division case, the code that we just added in our IDE. So that's perfect. But if we go to GitHub, we'll see that in demo.c, it still has this to do make the division case or to do divides. So let's make those changes now. So we'll go back to git bash. And now that we have changed demo.c, what we can do is we can do git add demo.c. And what this does is git add adds it to the staging area because we have our working directory and then we have the staging area. And this is from the staging area, we can commit to our local repository. And then from our local repository, we can upload it to the remote repository. So let's see what we have in our staging area by git status. And we'll see, okay, we modified the demo.c. So that looks good. So let's do a quick git pull because I see we have some errors here. So let's make sure that we are up to date with origin master. Okay, so it says we're up to date, so that's good. Next, we will try to commit these changes. So we can do git commit -m. And our message for this commit will be that we're adding a division algorithm, sure. All right, so it says we have 1 file changed in our local repo. So that's great, no errors there. So let's try to see what's in our staging area now because we put it in the staging area and then we committed. So let's see what that did to our staging area. So our staging area no longer has this green file that says demo.c, so we are all good. So now you'll notice that this still hasn't done anything to master, it's still the same, but let's change master. So we'll go git push the U flag for our upstream that we set, and we set our upstream to our origin, which is the remote repository. And let's push it straight to master. Normally, I wouldn't advise doing this. I would advise pushing it to another branch. So actually, let's do that. We'll create a new branch. We have some branches here already, but we'll create a new branch. We'll say add division. We'll hit enter. All right, and just so we're sure that we have the same code, we'll pull again from the add division. All right, so it's looking good. We don't have any errors, so let's put this into this add division branch. So we'll do git push the U flag origin, and then we said we'll add it to add division. All right, that it probably messed it up when I did the when I changed branches. So we will just try to push it to master then. Yeah, so if you want to do a new branch, do it before you make your changes. That was my bad. That's one of these things where you always might forget something in Git, but there's still a way to push it. So just to make it clear, what we did is after we changed the IDE code, or the code in the IDE, we said git add and the file that we changed, which was demo.c, and that added it to the staging area. And from the staging area, we can commit. So then we said git commit -m adding division algorithm. And so it's perfect. Okay, that's committed to our local repository. It's no longer in our staging area. And then we'll push it to master. So we said git push u origin master. So now let's see if anything updated on our GitHub page. So we're in the add division branch. So let's switch to master. And we see, oh, here's our comment. We said adding division algorithm in our commit message. And so it's shown here. And so let's go into demo.c. Let's see what got changed. Okay, so we added our algorithm just like we did locally, and the division algorithm, the division operator is changed as well. And so let's now try to make sure we have the most updated code. So after you have a teammate that pushes, make sure that you all pull the most recent. It won't change anything for me because I'm the only one working on this right now, and I was the one who pushed the changes. But it's a good idea after somebody pushes to just pull from the new master to make sure you have the most updated code. And so we're already up to date, but now we have these changes on GitHub, and we've added this division to our calculator. So again, with the branches, I kind of messed up. So if you want to do this branch thing, well, I guess we could do it now. It still has the to do because we didn't create the branch, but let's see if we create a branch from master now because master is updated. So let's say we'll just call it something dumb like branch 1. And so now our branches should have the most updated version from master. Let's do this. Okay, so it still says to do. I'm not quite sure why, but we have master, and we updated master with our new division algorithm. So hopefully this kind of shows you the workflow. We want to make sure that we have our local Git repository, but we also have our global. And you can constantly see the changes between those two by checking the files in your local through either this like bim command, since it's a Linux terminal, or opening your file system and opening those files in an IDE. And so hopefully this gave you a little bit more information about the process. I know we didn't cover pull requests, but that's what would happen if I had a new branch. So let's say I had a new local branch, checkout branch, we'll call it new branch. So if I had a new branch here and I made changes here in this new branch, let's say I did everything that I did with the division. I opened it in the IDE and I changed code, and then I wanted to push this new branch to the GitHub repo. If I push that from this new branch, it'll pop up on GitHub with a option to pull request. And what a pull request looks like is you can pull from any of these branches. It'll compare add division to master. It says right here, there isn't anything to compare because add division and master are the same. But let's see if we have one that's different. No, they've already been committed. So, but this pull request is where you can kind of see what's been going on, who is trying to push new changes, and this is really where you can kind of work as a team. So sorry we didn't get to see that because I messed up with the branches a little bit, but hopefully you get the idea of how to use these GitHub commands. And so if there's any questions, now
we do have one question. We do have one question in the Slido. Someone asked, what CS class would you start to use GitHub in?
So personally, right now, I am in like a data structures course, but I think that, so GitHub, it gets taught in, I think it's application programming, if I remember right. But I think you start to use GitHub outside of classes before you'll use it inside of classes. Whether you go to a hackathon and you're trying to do a project, or yeah, thank you, Zach. It is app programming. So it's whether you go to a hackathon and you're using it for a project to collaborate with your team, or whether you take on a personal project and you don't want a bunch of files on your local system named like file 1, file 2. And so I think that you use it a lot more before you get to it in classes, hopefully before you do in classes. But if not, you'll start to learn about it in applications programming. Were there any more questions in the YouTube? Will you make these slides available later? I'm open to that. I would be happy to put these slides in the Slack, but also this video will be posted to YouTube. So feel free to run it back and kind of go through the demo with me. Obviously, there were some errors with the branches, but you can kind of go through the slides and go through the demo with me as we put it on YouTube after this presentation is over. All right, I don't have any of the chats up, but if you have any questions about GitHub, feel free to reach out. And I hope that you learned something today. If not, just the concept of Git and GitHub, what it is, it can be a useful tool. And so I'll pass it back to Vanessa to kind of close us out and give a little reminder here of the things we have going on for ACM the next week.
Yes, thank you, Janelle. That was a very nice presentation and a demo. I think it's very useful. We do have some, like I said, events going on throughout the week. I couldn't find the QR code for the ACM-W meeting and the general ACM meeting, but you can log into Slack and this information is available there. We do have these 4 events going on, so please check them out when you have a chance. And that concludes this presentation. Thank you all for joining us.